Okay, so in this video, we are going to be looking at section 4.1. Section 4.1 is solving quadratic equations. So remember, the general form of a quadratic equation in one variable looks like ax squared plus bx plus c equals 0 with a not equal to 0. Now we want a to not be 0 because if a is 0, then notice we're doing 0 times x squared, and anything times 0 gives you 0, so that would go away. We would be left with bx plus c equals 0, which is a linear equation. So if we want to make sure we have a quadratic, we need that a to not be 0. So remember, when we're solving the quadratic equation, that solutions stem from the zero factor property. The zero factor property says that if a times b is equal to 0, then a is equal to 0, or b is equal to 0, or both are 0. So when we're solving the quadratic equations, we have three ways to solve. We can solve by factoring, we can use the square root property, or we can use the quadratic formula. Now, hopefully you remember these from high school. We do not teach factoring in this class. We are going to do a few examples just to kind of refresh your memory on factoring. But for a good review of factoring, check out section 1.3 in the textbook. Email me if you have questions or need help with factoring. And then don't forget about the ARC. They can help with factoring as well. So we're going to solve a few of the examples here. The first one, we have x squared plus 4x equal 21. Now remember, the zero factor property says if two numbers are multiplied together and the result is 0, then one or the other or both must be 0. So we're looking for two things that multiply together when the result is 0. So we don't want this to be equal to 21, we want it to be equal to 0. So the first thing we need to do is to move the 21 to the other side. So in order to do that, we subtract 21 from both sides. We get x squared plus 4x minus 21 is equal to 0. Now we have to factor. We have to figure out what two things multiply together to give us x squared plus 4x minus 21. Now, there's lots of different methods. If you learned one of those, you're welcome to do it. But basically, factoring is just unfoiling. You're looking for what do we have to do in order that when we FOIL, we get back x squared plus 4x minus 21. So remember, whatever goes here and here are going to be our first. They're going to multiply to give us x squared. These two are going to be our outer. These two are going to multiply to give us the inner. When we combine those, we should get a plus 4x. Whatever goes here and here has to multiply to give us negative 21. So when we are figuring out how the factors go, we know x and x have to go here, so that x times x gives us x squared. And then here and here have to multiply to give us 21. So we can use 21 and 1, or we can use 7 and 3. Sometimes you have to try, guess and check, use different options until you find one that works. So we're going to try 7 and 3 here. Then the only thing left to figure out is our sign. Since this is a negative 21, I know one of these needs to be positive and one of them needs to be negative. And they have to combine the outer and inner to give me a positive 4x. So I get a 3x from the outer, a 7x from the inner. If the 7x is the positive and the 3x is the negative, then I get a positive 4x. Remember, we can always go back and check by FOILing. X times x gives us x squared. X times negative 3 is negative 3x, 7x, that does negative 3x and 7x do combine to give us 4x, and then 7 times negative 3 gives us negative 21. Now the zero factor property, we've got two things that multiply to 0. That tells us either the first one is 0, or the second one is 0, or both are 0. So x plus 7 is equal to 0, or x minus 3 is equal to 0, or both. So solving both of those, we get x is equal to negative 7 or x is equal to 3. Now remember, with quadratic equations, with any equation, when you're solving, you can always go back and check your answer. Plug in the negative 7 for the x here and here, simplify, you get 21. Plug in the 3 for the x here and here, simplify, you also get 21. So we do get two answers that both work in this case. Now notice on the next one, we've got 6x squared plus 3x equals 0. And it doesn't have that last term, that plus c, that we're supposed to have. So in this case, without that plus c, we know that they both have an x in common. And if we look closer, we can see that they actually both have a 3 in common as well. So we can pull out a 3x. So when we factor out 3x, we're looking for 3x times what gives us 0. Well, in this case, it has to be 2x plus 1. So that 3x times 2x gives us 6x squared, and 3x times 1 gives us 3x. Again, using the zero factor property, we know that either 3x is equal to 0 or 2x plus 1 is equal to 0. We can solve them both. Divide both sides by 3 here, you get 0. And then move over the 1, divide by the 2, we get negative 1/2. Again, we've got two answers. You can check them both. They both do work. Now on the next one, we've got 3x squared plus 36 is equal to 24x. Again, we've got to get it equal to 0 first, so we have to move the 24x over, putting it in the middle so it's in the order we like. Now, when you have something other than a 1 as your leading coefficient, when the coefficient for the x squared is not a 1, it is harder to factor. Not impossible, it's just more difficult. But in this case, with it being 3, and then we notice that all of our terms have a factor of 3, then we can get rid of that 3 by dividing both sides by 3. As long as we divide on both sides, we're legal. When we divide on the left, we divide everything by 3. We get x squared minus 8x plus 12 is equal to 0. When we divide on the right, 0 divided by 3 is still 0. Now we've got a leading coefficient of 1, makes it easier to factor. So we know we need x and x. The factors of 12 could be 1 and 12, 2 and 6, 3 and 4. Looks like it's going to be 2 and 6 here because that would give me a 6x and a 2x. That'll combine to give me 8x. Needs to be negative, so both of these need to be negative so that I get a positive 12 there. Double checking, x times x gives me x squared, minus 6x for the outer, minus 2x for the inner, combined to give me negative 8x, and then negative 2 times negative 6 gives me positive 12. Setting on both equal to 0, and solving, we get x equal 2 and x equals 6. Again, they both do work when you check them. All right, here we've got 9x squared minus 1 is equal to 0. Again, we've got a leading coefficient other than 1, makes it more difficult to factor, but not impossible. We can't just divide by the 9 this time because then we'd end up with a fraction, and it's even more difficult to factor when you've got fractions or decimals. So we're going to try to factor this. We're looking for what goes here and here have to multiply to give us 9x squared. So either 9x and x or 3x and 3x. Again, we may have to try a couple of different options. If we try the 3x and 3x, whatever goes here and here have to multiply to give us 1. So that has to be 1 and 1. We need it to be negative, so we need one of them to be positive, one of them to be negative. Now notice when we double check, 3x times 3x is 9x squared. Our outer is a negative 3x. Our inner is a positive 3x. Those two do combine to give us 0 x's, so we don't have the middle term. And then 1 times negative 1 is negative 1. Setting on both equal to 0 and solving, we end up with negative 1/3 and positive 1/3. So again, two answers. They both work if you check them. Now notice the next equation is the exact same equation that we just did. 9x squared minus 1 is equal to 0. But we have a different way that we can solve it now. Remember when we're solving equations with just one variable, our goal is to get that variable isolated by itself on one side of the equal sign. We can do the same thing here since we just have one variable, even though that variable's squared. We can isolate it, get it by itself. So we need to move the 1 over and then divide by 9 so that we get x squared is equal to 1/9. And then to find out what x is, we can undo the squared by taking the square root. So we take the square root of both sides. The square root and the square cancel each other out. You get just the x on the left. And then anytime you're taking the square root, remember you always get two answers. You get a plus and a minus. And in this case, the square root of 1/9 would be plus and minus 1/3. Again, you get the exact same two answers that we got before, solving it a different way. This method, this one, is actually known as the square root property. It uses the square root property. The square root property says that if x squared is equal to b, then x is equal to plus or minus the square root of b. And so basically, if something squared, doesn't matter what that something is, if we have something squared is equal to some number, we can take the square root of both sides, and so we get that that x, that something, is equal to plus or minus the square root of that number. Notice this works when we don't have that middle term. We didn't have the bx term here. And so it works when we have no bx term, no middle term. So here's another example. Again, we want to isolate the x squared. So we move the 2 over and divide by the 5. And then we can take the square root of both sides. And so when we do, we get x is equal to plus or minus whatever the square root of 2/5 is. Now, those are your exact answers. This is as precise as your answer can get. If you wanted to know what that was approximately equal to, you could put it in your calculator and get a decimal approximation. But this is your exact answer. We've got another example here. Notice this one's a little different format, but it still fits our square root property. It's still something squared is equal to some number. Doesn't matter what that something is. Something squared is equal to some number, and so we can take the square root of both sides to get rid of the squared. So when we take the square root, on the left, the square root and square cancel, we get 4x plus 8. And on the right, we get plus or minus the square root of 20. We still need to solve for x, so we're going to subtract the 8 from both sides. So -8 plus or minus the square root of 20. And then divide both sides by 4. So -8 plus or minus the square root of 20, the whole thing over 4. Now, you could have, if you didn't recognize to use the square root property, you could have solved it by squaring the 4x plus 8, doing 4x plus 8 times 4x plus 8, foiling all that to get a quadratic equal to 20. You want it equal to 0, so move the 20 over, and then you would have to, it wouldn't factor, you'd have to do the quadratic formula, and when you did the quadratic formula, you would end up with these exact same answers. It's a lot more work to do it that way, but it does work. It does give you these answers. The quicker way is to use the square root property. Since it's something squared, we can take the square root of both sides and then solve from there. Now, these are your exact answers, except this is not simplified. It's not reduced. MyMathLab is going to want you to reduce your answers. So in order to reduce, we can't just reduce the 8 and the 4, because remember, the 4 is the denominator for the whole thing, for the 8 and for the square root of 20. It goes with both pieces. And so we have to reduce it, all 3 of them. So in order to do that, we first have to simplify the radical, the square root of 20. Now you can simplify a radical, just as a refresher here, if we can figure out the largest perfect square that will divide into that number. So remember, your perfect squares are numbers like 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 36, 49, so on and so forth. Those are your perfect squares. So we're looking for the largest perfect square that divides into 20. Notice 4 divides into 20, 9 does not, 16 does not, 25 and the rest of them will all be too big. So 4 is the largest perfect square that divides into 20. So I'm going to rewrite this. I'm not changing anything. I'm just going to rewrite it as the square root of 4 times 5. Notice I still have the square root of 20. I didn't change anything. I just rewrote 20 as 4 times 5. Then I can simplify because I can take the square root of 4. That gives me 2. I can't take the square root of 5, so I'm going to leave it as the square root of 5. And so the square root of 20 is the same thing as 2 times the square root of 5. And so we can rewrite what we have here, replacing the square root of 20 with 2 times the square root of 5. Then we notice that we can reduce all three of them now. They all three have a factor of 2 in common, so I can reduce all three of those by 2, and we get -4 plus or minus 1 times the square root of 5 over 2. All right, on the top of the next page, we're going to look at the quadratic formula. Remember, the quadratic formula says that if ax squared plus bx plus c is equal to 0 with a not equal to 0, then we can solve for x, and we get that x is equal to -b plus or minus the square root of b squared minus 4 times a times c, whole thing over 2a. Now, the a, the b, and the c in this formula come from your quadratic equation. The a, the b, and the c in your quadratic equation. Couple of words of caution, places I see students make mistakes. The whole thing is over 2a, not just the last part. If you have just the last part over 2a, it's wrong. If you'll put it in your calculator with just the last part over 2a, you'll get the wrong answer. So make sure it's the whole thing over 2a. And then the other caution is to be careful of your signs underneath here. Remember, if you're squaring a negative, that becomes positive. And then notice here you've got a -4 times whatever a and c are. The signs of a and c could change this into whether it, and could end up being either minus or plus depending on your signs of a and c. So be very careful of your signs underneath the radical. All right, we're going to do a couple of examples. Again, notice our quadratic ax squared plus bx plus c has to be equal to 0. So we have to move the 1 over. So we get x squared minus 3x minus 1 is equal to 0. At this point, we recognize that to put it in our quadratic formula, our a is going to be 1, our b is going to be -3, and our c is going to be -1. Now, the quadratic formula, it's good to write it every time you use it. It helps you memorize it. It also helps you keep everything all lined up. So once we've got our quadratic formula, we know what a, b, and c are. We just have to plug them in. So we get x is equal to, get negative, and then for b, we're replacing it with -3 plus or minus the square root of -3 squared minus 4 times 1 times -1. And then that whole thing is over 2 times 1. And so reducing, simplifying, minus a negative gives us +3 plus or minus the square root of -3 squared is 9. And -4 times 1 times -1 gives us +4. The whole thing over 2 times 1, which is 2. And then last step, we get x is equal to 3 plus or minus the square root of 13 over 2. Now, these are your exact answers. If you're asked for exact answers, that is as precise as you can get. Again, notice there's 2 of them. There's 3 plus the square root of 13 over 2, and there's 3 minus the square root of 13 over 2. Notice that cannot be reduced. The 3 and the 2 can't be reduced. The square root of 13 cannot be simplified, so there's no way to reduce that. So these would be your exact answers. If you were asked for or you needed decimal approximations, sometimes when we're graphing, we need decimal approximations to know where to put something like this on the graph. In real life situations, you're going to want to use decimals, decimal approximations. They most of the time will make more sense than an answer like this. So to find your decimal approximations, you just put these in your calculator. Now, when you put them in your calculator, remember it's the whole thing over 2. So either put the whole top in parentheses and then divide by 2, or do it in 2 steps. Do the 3 plus the square root of 13 first, and then divide that by 2. Remember, you get 2 problem, so you've got two answers. You've got 3 plus the square root of 13 over 2, which in your calculator gives you approximately 3.3. We've also got 3 minus the square root of 13 over 2, which as a decimal is approximately negative 0.3. Now on the next problem, we've got 4x squared plus 5x equal negative 2. Again, we've got to get it equal to 0, so we move the 2 over. So we have 4x squared plus 5x plus 2 is equal to 0. Our a is 4, our b is 5, our c is 2. We write the quadratic formula to help us memorize it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in, we get negative 5 plus or minus the square root of 5 squared minus 4 times 2 all over 2 times 4. Simplifying, we get negative 5 plus or minus the square root of 25 minus 32 all over 8. And then last step, we get negative 5 plus or minus the square root of negative 7 over 8. Now remember though, we can't take the square root of negative number. That gives us non-real answers. So that tells us that we have no solutions. And I've got a couple of examples here that I want you guys to try. So if you would, pause the video here, work through these problems on your own, and then when you're ready, hit play and you can watch me solve them for you. All right, so solving these, on this one, it will factor. If you didn't notice that it would factor, you could do the quadratic formula. You will get the exact same answers. The quadratic formula always works. Whether you can factor or not, you can always do the quadratic formula. Sometimes you can do the square root property. You can always do the quadratic formula. But this one does factor. It's harder to factor because the leading coefficient's not 1, but we can still factor it. We know it has to be 2x and x to give us 2x squared. And then the factors of 15 would either be 15 and 1 or 3 and 5. And so the placement of the 3 and 5 is going to make a difference. If you put the 5 here and the 3 here, notice you would have 6x for your outer and 3x for your inner. Those are not going to combine to give you a 7x. But if you do it the other way and put the 5 here and the 3 there, then 2x times 3x gives you 6x, and then 5 times x gives you, that's the way I said not to do it, right? That gives us a 6x and a 5x, which won't combine to negative 7. But if we flip them around, notice we get a 10x and a 3x. Those will give us negative 7 if we have our 10x being negative and our 3x being positive. Again, we can always double check. We get 2x squared minus 10x plus 3x gives us minus 7x. And then 3 times negative 5 is negative 15. Setting them both equal to 0 and solving, we get x is equal to negative 3/2 and x is equal to 5. Now, if you had done the quadratic formula, when you simplify, you get to x is equal to 7 plus or minus the square root of 169 over 4. Now, the square root of 169 is a perfect square, so we're not done. We have to keep going. The square root of 169 is 13. So we can simplify that to 7 plus or minus 13 over 4. We're still not done because we've got 2 problems to work now, and we can get 2 answers. So we've got 7 plus 13 over 4, and we've got 7 minus 13 over 4. Notice simplifying, 7 plus 13 is 20. 20 over 4 gives us 5. Here, 7 minus 13 is negative 6. Negative 6 over 4 reduces to negative 3/2. So you get the same answers from doing the quadratic formula that we got from factoring. On the next one, again, we can do the square root property here because we have the something squared is equal to 4. And so if you didn't recognize that, you could FOIL this, move the 4 over, and then either factor or use the quadratic formula. You'll get the same answers, but the quickest way here is to do the square root property. Take the square root of both sides. That leaves us with 3x minus 5 on the left is equal to plus or minus, and then the square root of 4 is 2. And then we just need to solve for x still, so we move the 5 over and divide by 3. And so we get x is equal to 5 plus or minus 2 over 3. Again, we've got two problems to work. We've got 5 plus 2 over 3, and we've got 5 minus 2 over 3. So we get 7 over 3, and then we get 3 over 3, which reduces to 1. So 7/3 and 1 would be our answers on this one. A couple of applications is all we have left here. The first one says the net income for Apple, A, in billions, can be approximated by the function A is equal to 0.877x squared minus 9.33x plus 23.4. And then notice in parentheses, they're just kind of giving you a domain here. They're telling you 6 less than or equal to x less than or equal to 12. That means this model, this equation, only works when your x's are between 6 and 12 inclusive. That's the only x's that it works for. And then they continue with where x equals 6 corresponds to 2006, and we're looking for the year in which the net income was 17.8 billion. So notice our income, A, that's our output. The year, X, that's our input. We're looking for the year. They give us an income. So they give us an output. So we're going to plug in 17.8 for A, and we're looking for the year. We're looking for X. So we get 17.8 is equal to 0.877x squared minus 9.33x plus 23.4. Now remember, we have to get it equal to 0 first, so we're going to subtract the 17.8 from both sides. So we get 0.877x squared minus 9.33x plus 5.6. Now that's obviously not going to factor, so we're going to have to use the quadratic formula. When we do, our A is 0.877, our B is negative 9.33, and our C is 5.6. I'm going to let you guys plug it into the quadratic formula on your own, just to save a little time here. But when we do, it should simplify to x is equal to 9.33 plus or minus the square root of 67.4041 all over 1.754. Now remember, this is an application, so exact answers probably won't make much sense, especially when we go back and look and notice we're looking for a year. Well, this doesn't look like a year. So we need to figure out our approximations. Put it in your calculator. Put both of them in your calculator. When you do the plus one, you should get x is approximately equal to 10. When you do the minus one, you should get x is approximately equal to 0.638. But remember, they gave us a domain here. They told us specifically that this model only works for x values between 6 and 12. Notice 10 is between 6 and 12. 0.638 is not. So that one gets ruled out. That one is not going to work. And we only get one answer here. We get x equal 10. And remember, we were looking for the year, and they told us x equals 6 corresponded to 2006. That means x equal 10 is going to be the year 2010. All right, last application on the next page. If the profit from the sale of X units of a product is P is equal to 100X minus 100 minus X squared, what levels of production will yield a profit of $2,175? So first thing we might want to do is rewrite this in the format we like it in. So notice we have P is equal to negative X squared plus 100X minus 100. All right, so notice in this problem that our P is the profit, that's our output. X is our number of units, that's the input. They give us a profit, $21.75, and they ask for what level of production. That means how many units. So we're looking for X. So we're going to plug $21.75 in for P, and we're going to solve for X. We know we got to get it equal to 0 first. So we can move the 21.75 over. So we get negative x squared plus 100x minus 22.75. And then if we're going to try to factor it, we probably want to divide the whole thing by a -1 or move everything over to the left, either way, so that that x squared becomes positive. And so when we do that, we end up with x squared minus 100x plus 22.75 is equal to 0. Now this one actually does factor. Little difficult to see, so if you didn't see how it factored, you can do the quadratic formula and you'll get the exact same answers. But if you recognize that it factors, then it's going to factor as x minus 65 and x minus 35. Again, we can check that. X times x is x squared. A minus 35x and a minus 65x do give us 100x. And then negative 65 times negative 35 will give us positive 22.75. Setting them both equal to 0, we end up with x equals 65 and x equal 35. Again, if you had done the quadratic formula, you get those exact same two answers, 65 and 35. Now, before we were able to rule out one of our answers, notice there's no reason to rule one out this time. They don't give us a specific domain that we have to fall within. If one of them had been negative, we could have ruled it out because we can't produce a negative amount of units. But in this case, they're both positive, so they both will work. And we get two answers. We get 35 units and 65 units. And so if you take a look here at the graph, we can actually kind of see what's going on in this problem. So this is our profit curve. This is a quadratic. The graph of a quadratic is a U-shaped graph called a parabola. And so this is the P is equal to negative x squared plus 100x minus 100. Now this blue line here, this, notice, is 21.75. This is the profit we were looking for. So this is P is equal to 21.75. And so notice we have a profit of 21.75 on our function, on our curve here, which happens to be at 35 units. And here, which happens to be at 65 units. Because remember, our X was the level of production, the number of units. And our Y, or our P, was the profit. And so as our profits start to grow, they hit 21.75 at 35 units, and then they continue to their peak, and then they start coming back down, and we hit 21.75 again at 65 units, and then